Hello everyone. The purpose of this video is to provide a holistic understanding of the 9 pillars associated with Industry 4.0. I'm your presenter, Dr. Javaid Butt. Industry 4.0 does not have a standardized definition, and researchers use different technological aspects to define it.
Industry 4.0 is characterized by cyber physical systems, digital twins, automation, data exchange, the internet, digitization. Now, there's a difference between digitization and digitalization. Digitization refers to just the data being transferred into a digital format so that you don't have to deal with a lot of that uncertainty. And digitalization is a much more holistic approach where you are looking at the organizational structure and how you can incorporate all the Industry 4.0 aspects within an organization. So one more thing that researchers tend to agree on are the pillars of Industry 4.0, and they are identified as 9 pillars. And just to highlight the fact that these pillars are nothing new, so to speak. When I say nothing new, what I mean is these technologies have been in existence for quite some time. For example, the very first one that we have, additive manufacturing, the very first additive manufacturing system was commercialized in the year 1987. So that's like more than 3 decades ago. And even to this day, this technology is making an impact on our lives. And I don't think I have to go into much details about additive manufacturing. The reason I say that is because I'm sure everybody is aware of the response that the additive manufacturing community has provided to the medical professionals by quickly and rapidly developing face masks, face shields, ventilator valves, door openers, hands-free door openers, and all of those things that the additive manufacturing processes are producing and providing to our medical professionals so that they can combat COVID-19. In totality, additive manufacturing is characterized by 7 categories. So all of these categories, as you can see on the screen, I'm not going to bore you with the details, but all of these categories tend to add something to the mix. All of these technologies work on the same principle by adding layers on top of layers. But the difference lies in how they add those layers. So one recent development that I would like to share with you is this dress right here that you see on the screen. So this is known as a proximity dress that has been 3D printed. And I'm sure there will be new styles coming. Currently, there is only one dress that you see on the screen. So what it does is it is incorporated with sensors and actuators. So upon recognizing the social distance parameters that we have to abide by according to the UK government regulations right now, you can very easily identify when you are invading somebody's personal space or somebody's social space. So that gives you an indication that, okay, it is time to back off and not go into somebody else's social space that might increase the risk of the spread of COVID-19. So again, a very useful thing that has been developed. And this is one of the main features of additive manufacturing. It allows you the freedom of design. You can pretty much design anything as long as you can make a 3D CAD file of it. It gives you the freedom of choosing different materials that you can utilize. It is very rapid and allows you to manufacture different products and reduces the lead time from design stage to the production stage. As I said, I mean, the additive manufacturing is one technology that I don't think that I have to go into much details because we have all seen the impact that it has on our lives. And one aspect that I would like to highlight here, and something that I have been researching on as well, is owing to this current situation with COVID-19, I think that there is a need to establish a network for additive manufacturing as well. So all the additive manufacturing market leaders need to come together to make sure that they can still share the designs, the production methodologies, the parameters for good printing and whatnot with everyone so that this can benefit the community as a whole. Because right now, one of the main reasons why we have been able to respond to COVID-19 at such rapid rate is because there is a digital sharing practice in place where designers are in contact with manufacturers who are in contact with the medical professionals. So this chain, this digital link is working very well. And we need to establish this link even further if, God forbid, we are faced with a second wave or even something much worse down the line. So with that, let's move on to augmented reality. Again, one of those technologies that is gaining a lot of momentum, a lot of steam, mostly owing to the fact that you can augment a 3D object in your own physical space and you can play around with it. For example, what you see on the screen is this gentleman is currently looking at different aspects of an exploration site where he doesn't need to be there physically, but he can still look at all the different aspects that are there. Augmented reality helps a lot when it comes to training new employees, when it comes to enhancing their capabilities. Research has shown that the performance of employees increase drastically if they are developed through augmented reality. They help to optimize even the production flow. And these are quite fondly used in industry with the use of some hardware. And there is a specific example that I will be going through towards the second section of the presentation. The combination of augmented reality with virtual reality adds a little bit more applications to the mix. So now, in addition to having a 3D augmented version of something in the physical space, you can enter a virtual space as well. And these technologies are making quite a lot of difference when it comes to industries, and specifically with regards to assembly operations, because if you can augment different aspects of the assembly operation, you can do that fairly quickly. On top of that, analyzing the different aspects of a machine or a system. For example, the figure number 1 on the left-hand side that you can see, this is right here where augmented reality has been used for maintenance operations. So it shows you if there are any issues with your current system, with your current product or your process, and it gives you details of how you should go about that. So imagine if it's late at night, the production is running, and you have a new operator on the production floor and he doesn't know how to do X, Y, or Z. These directions would be very, very helpful and would avoid a serious disruption in your production flow. So this is, one of the aspects of augmented reality. Then let's move on to the third pillar, which is simulation. Again, something that has been used in engineering for the last few decades, I would say. What simulation does is it creates a virtual environment where you can actually see how your product or how your process would behave under different conditions, under different aspects of boundary conditions that you can apply. For example, what you see on the screen is right now I am heating product between two heating plates. One of the heating plate is on and the other is off. And you can see the temperature distribution with time as the simulation runs. So these are very, very helpful because sometimes, even if you run an experiment, sometimes there are certain aspects that are hidden from us, from the naked eye, or from even an experienced observer. And these simulations allow you to go into every creak, every aspect of your product or your process, and allow you to identify problems that you might oversee in a simulation. So they are very, very useful tool. But one thing we need to be careful of when we talk about simulation is the fact that these simulations should always be validated. So there should always be an experiment accompanying a simulation to make sure that the difference in the simulation results and the experimental results are within acceptable range. Because without that, you can simulate pretty much anything and you will pretty much get a result out of anything. But there is a saying that we use quite a lot when it comes to simulation, and that is garbage in, garbage out. So you want to avoid that scenario, and you should always, as I said, validate your simulations through experiments. So all of these work that I'm showing you, they are my work and they have been validated through experiments. So this right here is a simulation where I will run the simulation, but let me just give you a brief idea of what it is that I'm trying to do here. So in this case, I have a container. The container has water inside of it. And this white thing that you see in the middle, this is a device. This device, I want to know whether this device will stay at a constant temperature, because this is needed for a specific application. So one way that I have identified of making sure that I can get that uniform temperature is by pushing a stream of cold water from the bottom side of my container. So if you focus on the right hand side, the bottom side will be sprayed with a stream of cold water, and on the left hand side you can see the temperature changes as that stream fills through my already available liquid in the container. And on the right hand side you will be able to see the velocity magnitude as that stream continues to run. So let me just play this, and I want you to observe how these contours change and how you can identify exactly what is happening at any given time, so you can make an informed decision how to go about with your experiment. So as you can see, the stream is starting from the bottom, and as it is doing that, on the left-hand side, you can see the temperature coming down. The red aspect is the high temperature, and again, with the velocity contours, you can see the different temperature changes. So now the device that is in the middle, that is what I want at constant temperature, and that is what I can get running a simulation for a few seconds. So this gives me the confidence that yes, my idea is correct. Now I can move on to the next phase, which is validating this simulation that I have just run to ensure that, yes, I am on the right track. So it is a very useful tool when we talk about product development or product optimization. And not just that, I mean, the products are what we are talking about, but obviously there are manufacturing processes out there as well that needs optimization. So again, there are a number of software packages out there. This right here, what you see on the screen, has been modeled in a software called Witness Horizon. There are tons more out there, Simul 8, Simplifact, and a lot of them that you can utilize, and they all pretty much work on the same principles of mathematical calculations that allow you to get to the finish line. So what you will see in this simulation is there's a product that is being manufactured, and as you can see at the bottom, you will be able to see the finished valve is the product that is being manufactured, the finished number of products as they are developed through this production flow. So by using this simulation, you can identify bottlenecks in your production flow. You can optimize your resources to ensure that you get the best results out of it. And you can even identify if there are any blockages, or if you are designing a new facility, you can work around with this so that even before going to the physical implementation, you will have a virtual model that will tell you exactly what you need to do. You can play around with different scenarios, different operating parameters, and at the end of the day, you can come up with the most optimized version of what you want in your facilities, and that will save you time, money, and resources. So let's have a look at this simulation right here. So as time go by, you will see that around the 180 mark at the bottom of the screen, we will be getting one product finished. So the production flow, as you can see on the hardener from the staging area, the product is moving from the first stage, which is where it was received as a metal bar with raw material. And as it went through different iterations, it allowed us to identify how the process is going, what do we need to change, and how can we get the best out of our production flow. Right, so moving on, we have autonomous robots. Again, as I said, these are not new technologies. We all are quite familiar with robots, and we have been using them in companies for decades now. Autonomous robots add a little bit more to it. What that does is it allows the robots to be more self-aware. They should be able to self-configure, and this will allow a level of autonomy to the robot, so that humans should only be working as supervisors and not necessarily be on the production floor doing these operations. There is another class of robots that has popped up, which is again making a huge difference to the industrial sector, and those are known as cobots, or collaborative robots. What they do is they augment the human capabilities that humans can do in their own physical limits. So humans can be working with a robot on the same product, or they can be used by humans. For example, an exoskeleton is a prime example of that, that allows humans to lift more than they are capable of in terms of weight. So these cobots, they allow humans to do more, to be more. An automated guided vehicle, again, is a very good example of that. And notwithstanding the inherent advantages of robots, like increased productivity, increased performance, all of these just get added together with these cobots, and we can do now quite a lot more with these autonomous robots as we could have done in the past. So the next one on the list is Internet of Things. Now you might be thinking that even to this point, the four that I have just discussed, they seem a bit scattered. They seem like one thing and the other and the other. Now these four that I'm about to talk about, they are very much, or they should be very much in conjunction with each other, because they complement each other very well. Now it is not to say that we cannot incorporate the other four that I had just discussed. It is just a matter of finding what fits within your organization. This is what I said. It is not a one shoe fit all kind of a scenario. So you need to pick and choose what you want and how that will impact your business. So as far as the Internet of Things is concerned, now this is with regards to the interconnectivity of our usage, the interconnectivity of different systems, different devices, different machines, and that data that we collect from these machines, the interaction with humans, that all is encompassed within the Internet of Things. Its use in manufacturing is termed as industrial Internet of Things. So it allows you to do quite a lot, and it allows you to be able to get to the point where you can utilize that and you can get a lot of benefits out of it. So one of the main aspects of Internet of Things is collecting data. When you connect a number of sensors with your existing system, for example, let's take a very simple example. This is one of the examples that has been utilized as actually a hallmark of Internet of Things, where legacy systems have been transformed into digital systems. There was an example with regards to a CNC machine, a very old CNC machine, and a lot of different aspects were added to it. A lot of different sensors were added to it. So imagine your CNC machine having this 5 sensors, and you attach 10 more sensors to it. Now the data stream has increased drastically. What can you do with all of this data? That is the main concern that you should be having, because number one, you are not familiar with this data, and number two, you don't know how to use this data to make informed decisions. This is exactly where big data analytics come in. Imagine collecting all of this data from all of these different sensors and trying to make sense of that data. Big data analytics allow you to do that. It gathers the data, it analyzes it, it transforms it into a form that is understandable to you. It makes sense of the data so that you can make informed decisions using it. So in terms of data, we have 4 different types of data sets that generally gets developed. Number one is structured data, then semi-structured data, quasi-structured data, and unstructured data. And as you can see from the graph on the screen, the more we work with are the structured data. But the unstructured data is increasing in growth as we speak. Why? Because as I said, now we have way too many sensors and we don't really know what to do with all of that data. And making sense of the unstructured data is one of the most difficult things to do. And big data analytics allow us to do all of that. So what exactly do we need to do with this data? I mean, it is a good thing to have data. I would like to know much more about the Bollywood actresses and the Bollywood actors and which new movie is about to come. But what exactly am I supposed to do with that data? Am I supposed to plan my next weekend to go and watch that new movie? Or am I supposed to just keep up to date with that information? So it is all about making decisions. So what big data analytics allows you to do, it allows you to look at 4 different types of analytics. Number one, it gives you descriptive analytics. what is happening within my business. It is a very, very useful thing to have. And sometimes at the top level, at the senior management level, the shop floor or the operational floor intricacies can be overlooked, but the analytics, the big data analytics, does not allow that to happen. So it provides you with descriptive analytics. It provides you with diagnostic analytics. Why is it happening the way it is happening? Why are things going wrong? Why the last 2 weeks my production did not reach my planned mark? Why has something gone wrong? So these diagnostic analytics are very important, so that we can identify where the problem is and we can solve that problem to make sure that it doesn't happen again. Predictive analysis, we have been using this for decades. I mean, how do you think the weather people tell us it should be 28 degrees outside, or it should rain the day after tomorrow? That is all predictive analytics. And last but not least is prescriptive analytics. What do I need to do? If by running, let's say, simulations, if by attaching a lot of sensors and getting a lot of data, I find out that after 50 more runs, my product will fatigue and it will crack under the load that is being applied to it. What can I do now? This is where prescriptive analytics come into play, and you can very easily utilize all of this data, all of these analytics to make informed decisions. We now in this day and age are much more informed than we were even 5 years ago. So this is the time to take advantage of these aspects and be much more skillful and mindful of how we incorporate changes and where should we invest in terms of our time and our resources. So again, with big data analytics, we then move on to cloud computing. So I'm sure by now you would have gotten a sense of what is actually happening. We are only talking about technologies that are digital in nature. When I say digital in nature, they mostly deal with the internet or a digital format of working, and that is the hallmark of Industry 4.0. So why exactly do we need cloud computing, you might ask? Well, imagine having all of that big data sets coming your way through the Internet of Things, and the big data analytics trying to crunch those numbers, trying to give you the best analytics that it possibly can. Now, I'm sure you would understand crunching those numbers, running those analytics require a very, very sophisticated system. So imagine buying a 50,000 pound computer that can run such software packages, that can show you such analytics in a timely manner, mind you. I mean, there's no point getting the analytics after 3 days when the problem occurred on day 1, and 2 days you are simply waiting for the analytics to finish. That will not serve you any good now, will it? So this is where cloud computing can help. Cloud computing allows different subscription services where you do not need to buy expensive hardware, and all of that computing, all of that number crunching can happen on the cloud. So it allows you to save time, it allows you to save money on hardware upfront in terms of capital cost, and different cloud subscription services are available that can be utilized for a private cloud, as you can see on the screen. So it can be used by an individual, it could be a public cloud that can be used by an organization, or it could be a hybrid cloud that can be used by both parties. So again, these services are, they can be subscription based, they can be pay as you go, they allow you a lot more flexibility, and they allow you not to invest too much, because imagine if you are a small or a medium enterprise, you might not have that much cash to throw around on such things, but a large corporation can get all the benefits of cloud computing fairly easily. So this is one way of alleviating those issues, where you can incorporate cloud computing in your system, and if you don't need it for the rest of the year, you can simply cancel your subscription. If you only need it for a specific time, for a specific duration, you can do all of those aspects through cloud computing, and it allows you to do all of that. So again, combining Internet of Things, big data analytics, and cloud computing. And since we are talking about digital stuff now way too much, cybersecurity cannot be overlooked. This is why it is one of the pillars of Industry 4.0. Imagine getting all of this data with all the information in the world that you can think of, personal information, product information, process information, your new plans, what do you intend to do in 5 years' time, all of that. Imagine if it gets hacked. Imagine if somebody holds you at ransom to give you X amount of money so that they do not leak your information to the world. And I'm sure we are all aware of all the scandals that have come about that. The scandal of when Facebook had lost all their personal data, and when some emails got leaked from Hollywood executives, and in the candidate race between Donald Trump and Hillary Clinton. Don't want to go into those details, but my point is cybersecurity is a very, very crucial part of Industry 4.0. You need to be able to protect all of this data that you are generating to make informed decisions, to have a good control, a good solid control onto your systems. And all of this is done through cybersecurity. Right, so this brings us to the last pillar of Industry 4.0, which is horizontal and vertical integration. And this is precisely why I wanted you manufacturers, you people working in the manufacturing sector to understand what these technologies are, so that when you reach towards the horizontal and vertical integration, you would be able to understand and appreciate their implementation. So the aim of the horizontal and vertical integration is to develop organization-wide protocols for data sharing to create the basis for an automated supply and value chain. This is the ultimate goal of Industry 4.0, to allow you, to give you the freedom and the flexibility to be able to integrate all of these different aspects within your factory, within your organization, so that you will have all of these advantages at your fingertips, and you don't have to do an analytics, you don't have to do analysis every now and then to come up with a new system, come up with a new design. All of these things, they go hand in hand, and when they do, we move on to something that is known as a smart factory.